All right, so on number 5, so the shapes below, we want to see if it has symmetry. If so, sketch that line of symmetry. If it has rotational symmetry, tell the angle of rotation and its order. And if it has no symmetry, you write none. So let's go ahead and go on and see what number A is here. Number a regular pentagon. What does that mean to be a regular pentagon? I think you guys all imagine your head what a pentagon looks like. What's a regular pentagon?
It's not weird.
It's got 5 sides, pentagon, 5 sides. The word regular, and you probably haven't seen this much, we'll do more of it later though. Whenever you hear geometry, the term regular, that means everything's the same, is what it means to. So it's a 5-sided figure where all the sides are congruent. Because you can draw a pentagon where not all sides are the same, but a regular pentagon means all the sides and all the angles will be the same. So I'm going to go ahead and draw one. I'm really good at drawing pentagons, all right? Watch how I'm going to freehand this with my hand, okay? Ready? Look at that. Just sketch that myself. Thank you. Thank you for the applause. It took years of art school to get to this level, but I made it. So there's a pentagon, there's regular, all the sides are congruent, and those interior angles will be congruent as well. So we want to see, does this have any lines of symmetry? Yeah or nay? Does this have lines of symmetry? There's somewhere on here, Colin says, and I agree with that. Where? I don't know. I think it's nice green to see where they're at. Well, I can see this guy right there, right down the middle. Most of you guys had that. When you did this on your little quiz, you can see that one's going down. Again, just do your best sketch. It doesn't have to be a Picasso like my work of art up here, but just do your best. All right? Now, this is what a lot of people do, and you'd be wrong, especially with this shape. You try to connect the vertices. Sometimes it works out. If you did like a hexagon, we know hexagons and vertices will go across. But some people said, all right, this is. People did this on the rectangles too. Is that a line of symmetry? If I fold this part over itself, would that be the same image? No. So don't you dare draw that one. But I can't draw all the ones here because there's 5 sides. I can go from this vertice straight down to this side. That one, I can fold that in half. That works out. I can go from this vertice to that opposite side. These are actually perpendicular bisectors. If you guys want to blast from the past. This vertice is over here. And then my last one right here. So, does this have a line of symmetry? If so, how many? 5. I like it. Again, you can count them all up, divide by 2. Or we just know that we have 1, 2, 3, 4, 5. So, what about the order? Can I rotate this figure? If so, how many times can I rotate this? You guys, some of you guys are already recognizing the pattern. What will be the order of this shape? 5. It is 5, because I can rotate this 5 times, and it would still look like the same image. So I'm just going to do a quick little sketch so you can see this. You guys can turn your paper. I cannot, so I can turn the board. So I can rotate this a certain number of times. Watch. 1, 2, 3, 4, 5. So I can rotate this 5 times, so I do have an order of 5. Huh. How many sides are in this shape? 5. What's the order? 5. Oh, why is that? It has to do with regular figures. All right, now what about the angle of rotation? We said we can rotate it. How much? So angle of rotate. I'm reading. How do I figure out the angle of rotation? Yes, you. 360 divided by the order. Why 360? Because we're going a full circle, and I'm going to divide by the number of rotations that I can do, and that's 5. So each time I move that little pentagon around, how much did it move each time? 72 degrees. There's 72 degrees outside. Sorry. All right. Questions, that guy? Most of you guys did pretty well with that. What about this old Batman thing, where, you know, Batman or Robin punch someone and then the pow, whammy pops up? See what I'm saying there? That's what it looks like. You guys all read Batman comics? I guess not. All right, so this little symbol right here, I don't know what it is. It looks crazy. It's like it's a hedgehog shape or something. I don't know. Does this have a line of symmetry? Can I fold this at any point in time on itself to make the same image. There's anything symmetrical about this shape. So does this have any, can I rotate this figure? Can I spin this figure around some direction to map it onto itself where it's the same exact figure?
No, it's an oval shape.
It's kind of an oblong shape. I see what you're saying with spikes coming out every which way. So no. So does this figure have symmetry at all? None. Doesn't have any rotational, doesn't have line. So we got a big fat none on this guy. And we'll put in quotations. No, so that's right here. No rotation on that guy. What about this one up here? This one that kind of looks like a flag waving in the wind. Does this have line symmetry? Is there a way for me to draw a line through here that would make that the same? Is there? Is there? Possible? Well, what about this line? Huh? This line work right here? That's like, okay. That line? That line? That, okay. Not gonna work. I'll say right now. There's no line of symmetry on this guy. Is there a way to rotate this stuff? Can I rotate this figure to map it onto itself?
180 degrees.
You were saying turn it upside down, Jason, 180 degrees, right? And I like where he's thinking right there. So here, just sketch this. You can see this. If I take that figure and Jason says 180 degrees, turn it upside down, guess what? It's back on itself. So guess it does. So this one does not have a line of symmetry, but what is the order? How many times can I rotate this? Now, we rotated it one time, got there. I can rotate it back to the starting position. So it really has an order of what? How many times can I rotate it? 2. Yeah, exactly. That's how he got that number. So I can rotate it twice. That's its order. Define my angle of rotation. I can spell it great too. Angle of rotation. I'm going to take 360 again, divide by the order. Order happens to be 2. All that tabulation you got out there, you do get a rotation of 180 degrees. Little stars all around. Questions with that? Okay. Ready, set, 6.
Okay, if we look at 6, we want to map square A, B, C, D onto A prime, B prime, C prime, D prime. Right? Select all the transformations that could happen, perform. So which one are we moving? The top square or the bottom square? How are we going to remove the top square? Yeah, the little, or someone say it. Yeah, bottom square, tick marks or prime marks, top one doesn't. So that's the one we're moving. We're moving the one that does not have those tick marks or prime marks. So all we have to do in these type of questions, you just go down your list, perform each transformation, see which ones work, see which ones don't. So this first one, it says the reflection across the line y equals x. Well, let's go ahead and draw it. When you have these lines, you start at the origin, go up 1 over 1. 1 over 1, up 1 over 1. And down 1 over 1. Connect. Okay, so we do this, pick a point. Which point do we want to do with? A, B, C, or D? A, B, C, or D. A. Well, if we're reflecting A over this line, what do you notice about the location of A? On the line. And when that happens, does that point move at all? When a point's on the line you're reflecting over, do we move it at all? No. So if we don't move that point, is it going to reflect onto the other one? No, because it's not moving. We want A to be here. Well, if it's on the line, it's not going to move. So this one doesn't work. If that's like, I'm not not sure, that's really tricky. Pick another point. If we look at B, we're going to count 1, 2, 3. Again, when we reflect over that slanted line, we went down 3. Do you want to go to the left 3 or to the right 3 if we're going across that line? Right. If we go 1, 2, 3, well, B lands up there. We want B to match up with B prime. It doesn't. So again, that's why that one doesn't work. Picking A might be tricky to recognize because it's right on that line. And then if that's confusing, then pick another point. Okay. For 6, it says a reflection across a line y equals -2. Let's try that. We graph that line. Again, we're not adding anything, so we just start at the origin. And this time our slope is -2. Look down 2 over 1 or up 2 left 1. Okay. We'll pick any point. Doesn't matter which point you want to deal with. A, B, C, or D. Doesn't matter. A. Okay?
Cool.
Well, let's take a look at A. We try A. Count till we touch that line. 1, 2, 3. Which direction do we have to go? Left or right to get it across that line? Go right or do we go left? Go 1, 2, 3. Do those match up? Nope. Was that going to be your answer? Nope. A 180-degree rotation clockwise about the origin. Well, with 180-degree rotation, does clockwise and counterclockwise make a difference? No, doesn't matter. The rules still apply. So 90 and 270, that change. So again, pick a point. Which point do we want to deal with? Look at B. B, its location is 1, 4. Okay? So B prime, when we do that transformation, do we flip the point at all when we do 180 degrees? Nope. What happens to the signs? It's changed. Alright, well, let's plot that point. -1, -4. Did that match up? Yeah. If you want to, check the other ones. Let's check A. A is at 1, 1. So we change those signs, negative to -1, -1. Matches up. And if you did the same thing with C, C is at 4, 4. When you flip the signs, you get -4, -4. Matches up. And then the same thing with D. When you change the signs, -4, -1, it matches up. You just go through, do that rotation, if it matches, you circle it or check it, or you want to circle, check, whatever. I know the box might need it. Check it. That one works. What about the next one? A reflection across the x-axis and a reflection across the y-axis. Do we have to do any work to know that this one is or is not an answer? What did we talk about yesterday? Alexia? Very good. When we have a double reflection like this, reflect over the x and reflect over the y or vice versa, it's automatically a 180-degree rotation. Well, what did we just say about a 180-degree rotation? Did it work? Yeah. So is this one going to work as well? Yeah. I'm going to do any math. We know those two things are the same, so we know that one's going to work as well. Okay? If you don't remember that, that's okay. Just reflect the square over the x-axis. 1, 1. What? 4. It's an x first, right? Reflect it over the x-axis. 1, 1. 1, 1. 1, 2, 3, 4. 1, 2, 3, 4. over the x-axis, then reflect it over the y. So count 1, 1. 1, 2, 3, 4. 1, 2, 3, 4. Matches. And then when you reflect it over the y, they all end up matching up. So you don't remember that little trick, do the transformations. You're going to get the right answer, just a little more work. Okay. Got one more to do. Let's see if a 270-degree rotation counterclockwise about the origin, then a reflection across the x-axis works. Okay? So when we do 270-degree rotation, and you have to write those points down. So A was 1, 1, B was 1, 4, C was 4, 4, and D was 4, 1. Okay? What happens to our point when we do a 270-degree rotation? Good. We flip the points, and then what sign do we change? The first or the second one? If it's 270. You change the... I don't have test over this tomorrow. Second one, good. So when we flip 1, 1, becomes 1, 1. Change the sign of the second. Flip 1, 4. Comes 4, 1. Change the sign of the second. Flip the point. Change the sign of the second. And flip the point. Change the sign of the second. Then go ahead and plot them. It's okay if this one doesn't match up, because we have a second one to see if it works or not. So plot those points. 1, negative 1. 4, negative 1. 4, negative 4. And 1, negative 4. Okay? So that's what we get when we do a 270-degree rotation. Then it's asking us to reflect it across back over the x-axis. Well, if we were to do that, is it mapping up with this other square? No, it's mapping it back onto itself. So would this one work out? No. If it asks us, hey, what would map this square onto itself, then that would be an option. But we want to map this square onto that square. So that's why it doesn't work out. Okay? Questions over that one? Go down, cross out the ones that don't work. Circle the ones that do.
Ready, steady, go. All right, number 7 over here. Multiple choice one, trying to see what's going on. So a rectangle is dilated by 2 about the origin. Then it's dilated by 0.5 around the point 20. Circle the final image. All right, that's easy. Well, there's some we can eliminate off the bat because we know we're not always dilating about the origin. We're dilating by 20 at the end. So which one of these can we eliminate off the bat because of that, knowing that new origin is going to be 20? You're saying B? I agree, because B is sitting at the origin right there for both of them. That's not good. We need one to be the origin, the other one be 20. Over here, this one's also at the origin. So that's gone. Now we're down to a 50-50 shot. We haven't done any work yet. Because see, I know it's either going to be A or D. How do I know which one's which? Okay. Well, because I'm dilating something, that's something where I need to definitely write down the points. And I'm going to pick one of these pictures over here, one of these images, one of these points, and I'm going to dilate it. The first one says dilate by 2. I'm going to pick this point right here. So I'm picking this point right there. Where is it at? Well, it might be hard to see, but this is sitting at 2.5, 5. So this point's at 2.5, 5. I want to dilate it by a factor of 2 first to see where it would be. All right, so I'm dilating by 2. What's that mean I do to every point when I'm dilating by 2? Multiply them all by 2. What's 2.5 times 2? 5. And what's 5 times 2? 10. So I want to see if this new point 510 is on this graph somewhere. Well, let's see if it is. Again, I only have A or D to figure it out. So A, if I go over to 510, is that at the bigger one? The one that's getting larger? Does that make sense? This one's larger than that one. Okay, that one works out. Let's go over here and see what 510 is looking like down here. 510. Is D going to work out? Did that image get larger? No. They do the reverse. It's hard to see on your paper, but there's a little rectangle inside there. First they did it, they made it smaller. Then they dilated by 2, so they did the opposite of that. So the only one that works is I don't need to go any further, because I know D's not going to be it, because they don't have that one mapped onto itself first. So A is my answer there. So the first one, the lighter purple, the lighter shade one, that's my dilation of 2. And the other one I slide over and I dilate it by 0.5. So that makes it, it's getting smaller. So there you go, cross elimination. Got down to a 50-50 shot. Then we eliminated the one we did just by picking one point. Do I need to do every single point? I had a question, or someone asked that earlier. No, I don't need to do every single point. Once I figure out that it's going to not match up, I don't have to go on. I stop right there. And this is multiple choice. We're just trying to limit the answers and make it easy for you. Questions on this? Yes, you.
Is our test gonna have multiple choice?
Possibly.
Solid.
Solid.
That's
25%.
nice.
Well, some have more than one right answer though, so you gotta choose that. All right. Generation. Okay, here we go. The triangles rotate 120 degrees clockwise about the origin. Whoa, pump the brakes. Got two things going on here I don't like. First one being what? What do I like about this question? Have we rotated 120 degrees before? Don't like that. What else don't I like about this? Clockwise. I hate both of those things. Don't like them. But guess what? We all have big enough brains. We can figure it out. Because we know which way clockwise goes, don't we? Don't we know which way clockwise goes? If you're confused, turn around, look at the clock real quick. It's going that way. Find the second hand, the little red hand going around. There it is. I found it. That's where I want to go. So it's going this way. It's going to the right. All right? So here's my pre-image. The pre-image is on every single one of these. And I want to see which one rotates the correct way. Well, if I'm here, my pre-image, I'm just going to pick this little point right here. That's an easy dot to locate. So let's not use red. Let's use black. It's a little easier to see. So I'm right there. And I want to rotate clockwise. Which way would this dot go? Would it go down or go up if I was rotating clockwise? So it's going down, right? So it's going down. All right. Well, let's see if we get down here. I'm going to go to that point right here. How do I get that dot, because that's the pointy end of my triangle if you're thinking about it. Where do I have to go from here to here to get there? I have to go down, right? Because I want to go counterclockwise. Going to that point right there. Right? Let's go clockwise. Could be good. What about this one over here? Here's my point again. I'm going to rotate it. I want to go clockwise. How do I get from there to there? I got to go all the way over here. Does that make sense? Look how far I traveled. Think about this as quadrants. Think about our rules video with our jumps. If I move from here to here, how many degrees is from there to there? 90. Because again, I go just one quadrant, it's 90 degrees. I go from here to there, that's another 90. What's 90 plus 90? 180. And I have to go a little bit further. So is there any way B can be the right answer? No, it can't be the right answer. All right, so he's gone. So I still got A with it not still. What about C? Look at C. Then laugh at C. Why can't it be C? It's less than I don't know about that. What are we rotating about here? The origin. What's this rotating by? Not the origin. So is it going to be C? C is C. So now we're down to D. All right, D looks like a good one. Let's see our starting point where we were before. And I'm rotating right there. So I did rotate clockwise. But what's the issue with D? It's less than 90, because we just said up here, 90, this dot sitting on the line, 90 would get you right there on that line. So it should be sitting right here to be 90. So this is less than 90, correct? And I want to move how much? 120, not less than 90. So process elimination with just knowing how to rotate clockwise and knowing our rules about 90, 180, and 270, we can figure out that the correct answer is E, as an elephant. I'm joking, it's A. There we go, it's not there. Questions on that one? Number 9.
We take a look at 9. It says triangle ABC has vertices 1, 1, 2.5, 3, and 0, -3. So let's go ahead and plot those points. And label 1, 1, 2.5, so it's right in the middle. 1, 2, 3. That is B, and then 0, -3, which is C. And connect. And oh boy. Oh my goodness. And the triangle looks a little doofy. We dilated this triangle by a scale factor of 1/2 about the origin to create a new triangle. What is the length in units with side BC? Okay. You could do the dilation and then find the length of your new side. But look at that current triangle. It's already messy to look at. If we dilated the by 1/2, do you think it's just going to get even messier? Yeah. So what we can do is just find the length of whatever BC is right now, and then whatever we get, multiply that by 1/2. And that's going to be the length of the new one. Okay? Well, what did we use last unit to find distance? What theorem did we use? No, we can use a Pythagorean theorem to help us find distance. Alright, we'll make your right triangle. We'll go down and then over. Up. Down. Stop. Okay. What's the distance of this side right here? 1, 2, 3, 4, 5, 6. Okay. The length of that side is 6. The bottom part's a little different because we're starting here at 1/2. So when you count, you're going 1, 2, we're not quite there. We have to go 1/2. So what's the distance of that bottom side? 2.5. Fill those values in your Pythagorean theorem. 6 squared plus 2.5 squared equals C squared. What is 6 squared? What's 2.5 squared? 6.25. 36 plus 6.25? When we do that? 42.25. What do we have to do to both sides? So what's the square root of 42.25? 6.5. So that's the length of the current BC. We want to know the length of the new BC. Well, again, what did we say we had to do with 6.5? It's a scale factor. What do we do with scale factors? We multiply. So you just have to do 6.5 times 1/2. What is 6.5 times 1/2? 3.25. So that would be the distance of our new side. Now, if the triangles are nice and neat, and we could easily dilate that one and plot it, we had room to kind of look at it, and you could have dilated that triangle, then found the distance of the new one. That would have been really messy. So this is another way of going around.
Yeah, teeny little triangle in there. Sorry, teeny enough. Right, Questions? Pythagorean theorem? Good. Ready? Number 10.
You can change this to select all, that's fine.
Yeah, I think I'm used.
This doesn't say that.
Yeah, it is. So the rectangle shown on the coordinate grid below, which of the following transformation would map onto itself? So I'm going to do some sort of move, and it's going to be exactly the same shape. So how do we do that? Well, let's figure it out. Let's go through. Again, make sure tomorrow might help you out. Have colored pencils, highlighters, something along those lines to help you visualize these things a little bit here. So we want to do a reflection across the x-axis. Well, where's the x-axis? I'll show you. Right there. So if I reflect these points across, what I like to do, I like to just highlight. I mean, you don't need to change and make letters, you can, but I just like to visually see these by drawing little colors on them so you can see it. So I want to reflect those points across that x-axis. Would it make the same exact shape? I don't know. We'll figure it out. So here, if I want to take this point, reflect it across, what do I do? Well, I count down. 1, 2, 3, 4. I went down 4, so go forward the other direction. 1, 2, 3, 4. Did it just map onto itself? Yeah, it did. The top one went down to the bottom one. I'll use it green to help you see. It is. It mapped onto itself. Let's do this other one, this top right one up here. 1, 2, 3, 4. 1, 2, 3, 4. It maps on itself again. Let's do the other point to see if this wasn't a fluke. Well, these go to it. Go up. 1, 2, 3, 4. 1, 2, 3, 4. Those map on. 1, 2, 3, 4. 1, 2, 3, 4. Ah, yes. It does. So can I reflect across the x-axis for this one? Would that make the same exact shape? Would it map onto itself? 50, sweet 50, it does. All right. What about B? Reflection across the y-axis. The y. Where's the y, you're asking me? Well, I'll tell you why. Right here. That's it. Same thing. Let's reflect across. I'm randomly going to pick this dot right here. Let's see what's going on. 1, 2, 3, 4. Go forward the other direction. 1, 2, 3, 4. Does that map onto itself? Does this blue dot go on the other dot the exact point? No. So it does not map onto itself, so guess what I can do with B? Cross it off. Don't need to do any of the points because one does not work, then the other one, it doesn't matter. Does not matter. What about this next one here? I do a rotation of 180 degrees about the origin. Would that work? I see some heads shaking, down, then side to side. Let's figure it out. Let's just pick one point. Let's do that same little trick here. Pick one point. I'll pick this one. It's positive. This point right here looks like it's at a 3, 1, 2, 3, 4. So I'm sitting at a 3, 4. If I want to rotate 180, what do I do with these points? Change the sign. No flip, just change the signs. So change the signs, and now it's going to become -3, -4. If that matches up on a dot, we're golden. Let's figure it out. -3. 1, 2, 3. 1, 2, 3, 4. Boom. Do those map up? No, they don't. So guess what I'm going to do to C? I'm going to slash it. Getting closer, getting closer. 90 degrees. Well, think about it. We can just easily think about the points too. If I'm doing 90 degrees about the origin counterclockwise, if I take this point and I rotate, let's rotate. Let's just rotate it. So I'll take that same point, 3, 4. How do you rotate 90 degrees? What do you do? Flip it, change first. 90 comes first. So I'm going to go ahead and flip it first. Let's go 4, 3. Change the first -4, -3. Let's see. -4. 1, 2, 3, 4. Then I'll go with 3. 1, 2, 3. Not going to map up on that blue dot any there. He gone. What about dilations? Is there anything dilating in this picture? If I make it bigger, smaller, do you think I would change it? What if I did a dilation of 1? It just stays the same, right? Dilation, you take all the points, multiply by 1. Anything times itself is itself, right? So guess what? E works. I'm just dilating by 1. And what about F? Dilation by 2. If I dilate it by 2, would it stay the same size? No. So could it be the same way, map onto itself? I'm going to say no. So it's not going to be no on that one. Where is it? Where is it? Green. No. So, Amy.
Sorry, go ahead and select all that apply in the directions, because if it doesn't specify if that select all that apply, then it's just one right answer. If it says select all that apply, then you need to go down through, even though you found an answer, there might be another correct one.
Okay, make sure you're reading those questions carefully. Ready, set, on set.
Last one, we have a translation applied to this triangle PQR to create the new triangle P prime, Q prime, and R prime. Let the statement XY to AB describe the translation. Create equations for A in terms of X and for B in terms of Y that could be used to describe the translation. Really wordy. Okay? Really, all that they're asking you is write a rule for this translation. That's all they're asking. They're just asking a really different way. So let's write a rule for this translation on our own and then see how we can put it into this answer. So they're talking about equations, so we're going to write our translation rule using equations. Which movement do we always do first? Do we go up and down or left or right first? Yeah, always want to go left or right first when you're doing a translation. So to get Q to be in line with Q prime, how far do we move? 4. In which direction we go, left or right? Left. So this equation is going to be x minus 4 because we went to the left. Okay? Well, how far do we go up? We went up 3, so that equation for the y's would be y plus 3 because we went up. It's positive. That's how we would normally write a rule, correct? When we were doing the equation way, we went left, so it's x minus 4. We went up, so it's y plus 3. And we still have to fill in those squares. But you notice A is written in the first spot here. What's written in our first spot in our rule we just wrote? X minus 4. So that's what A is going to equal. X minus 4. B is written in the second spot. Well, what's written in the second spot here? Y plus 3. So B will equal y plus 3. That's all they were asking. Write a rule. Well, A is in the first spot, so the equation for A is going to be x minus 4. B is in the second spot, so the equation for B will be y plus 6. Watch this over. Anything in your review? Anything clarified?